Ansible is probably the first tool that comes to your mind when you hear terms such as, for example, IT automation or network automation. It is a powerful tool that can really simplify the management of our infrastructure by automating tasks across, for example, multiple servers. But beyond making your workflows much more efficient, it can also significantly enhance the security of your development environment. Hi guys, my name is Simon and welcome to Akamai Developer. In today's video we're going to look at the 5 security features of Ansible that can help you manage your infrastructure efficiently and securely. And remember, if you are new to our platform or new to cloud computing, there is a link in the description to get $100 60 days credit. So sign up right now and follow this exercise with me so we can build the secure Ansible environment. And now, just before we go to the cloud dashboard, let's look at the setup that we are going to build together today. Okay, so in our lab, we will have 3 Linodes that we're going to use to show our security, Ansible security features. And the first one and the main one is the Ubuntu-based control machine. You might already know that Ansible is agentless, meaning that we don't really need to install the software on all of the machines. It's really enough if we install Ansible on one machine that later on we'll use to push the configuration to other machines. And apart from the control machine, we also have Linode 2 and 3. So these are the servers that will be managed by Ansible. So to make exercise more interesting, I decided to have one machine that is Debian based, which is also Ubuntu, just like the control machine. And another one will be CentOS. Okay, let's just now open the cloud dashboard and let's start the exercise. Okay, now I am on the cloud dashboard, Linodes cloud dashboard, and I'm going to create 3 Linodes. One is the controlled node and 2 Linodes that I will be controlling with the one that has Ansible already installed. So let's jump to it. First, let's create Linodes. It's just super easy, super fast. I will select Stockholm as this is the region that is closest to me. For first machine I'm creating is the one that will have Ansible installed, and that will be running Debian based Ubuntu 24. I don't need any big CPU or memory, it's just the demonstration, and I'm going to put here control Linode. Okay, I'm going to create a new password. And now I am not creating any SSH keys. I'm going to configure SSH a bit later in the video. Okay, excellent. So we have the first controlled Linode is being created. Let's in the meantime create 2 other Linodes that we're going to provision and manage with Ansible. Again, Stockholm, for the first Linode, I'm going to use Ubuntu 24, so just like a control node, and the second machine I'm going to provision with CentOS. Okay, again, the same configuration, nano node. So here is a Ubuntu Linode here, and the password. Okay, and I'm just continuing. Okay, so now I have the second Ubuntu Linode being provisioned. Excellent. And the third one, the last one, Stockholm. Here we will select the CentOS. We can see we have also other distribution, but for today's demonstration, I'm going to use 2 Ubuntus and 1 CentOS. Shared CPU, Linode label. So it's a CentOS Linode. Okay, and the password, I'm going to put the new one. Okay, and I'm just creating Linode. You see how fast and how easy it is really to create Linode to spin up the Linode on the Akamai platform is really incredible. Okay, so let's see what we have. Okay, so what we can see here, we have 3 nodes, 3 Linodes. First, we have 3 Linodes. First one is the CentOS, so the one that we'll be controlling. And then we have Ubuntu. We also have Ubuntu Linode, and then we have a control Linode, so the one where we have Ansible installed. Okay, excellent. Let's just now try to SSH to our machine. Okay, now I'm already SSH to my control node. There are 4 different commands that we need to run, and this is all from the official documentation from Ansible. So first we're going to run apt update, then we're going to run apt install software properties common, and then we're going to add the packages to the repository, and at the end we're going to run apt install Ansible. So these are just the 4 lines that we need to put to our terminal. And of course, if you already have Ansible installed, you can move forward to the labs when we are actually making the security when we're testing the security features. For now, let's just run all 4 commands here, and again, everything is from the Ansible documentation, and it's just running. Okay, I will just fast forward this part so we don't wait, and now the last part is just to run Ansible version. So we can see here that we have the Ansible version 2.17 that is based on the Python version 3.12, and we are all set. We are ready to go when it comes for our Ansible lab. Ansible security feature number 1, SSH. We can list many great features of Ansible. It is agentless, as I already mentioned earlier. It's idempotent, it's push-based architecture, it supports multiple different modules, and on top of that, it uses SSH to establish the connection with the remote host. But what does it actually mean that Ansible uses SSH? Well, let me explain. SSH key exchange is one of the most crucial elements of securing the communication between the host node or the managed node where we have Ansible installed and the remote nodes that we are going to provision, manage, and work with. So basically, instead of using the password-based authentication, we are using the private public key infrastructure to authenticate to our secure nodes and create the encrypted tunnel. Password-based authentication can be easily exploited, so rather than trying to authenticate and putting the password every time we need to push some configuration to our remote nodes, we can simply use the SSH public private key that can help us with really streamline the whole connectivity process and management of the nodes. Plus, it's much more secure comparing to the password-based authentication. So let me now show you a little bit of hands-on how you can also do it. It's also one of the first things you do when you set up the new Ansible project. You basically always need to secure your communication and exchange the keys between the host node and the remote nodes. Let's now jump to the console. Okay, I'm already in my control node, and so the first thing I'm going to do is to create the public private keys. So I would just go select the RSA type, and I'm going to create the keys in which file you want to save the file. I'm just going to leave it empty, enter. So the command I'm using is the SSH keygen. It's a basic utility in your SSH keys infrastructure. Okay, and we can see that we already have the public private key created in the .ssh folder. Now the next thing that we need to do is to distribute the public key to our remote nodes. This episode is not really about the public private keys exchange because it's just way too complicated. What you need to know at this point is that to authenticate or to create the secure channel between 2 different nodes, we need to distribute the public key, so the one that can be read publicly. To do it, I'm going to use the SSH copy ID, and here I'm going to select the user and the IP of our remote machine. So this is the first remote machine that I'm using, that with the IP ending at 170. Yes, I want to confirm with confirm the fingerprint, and now I'm putting the password that I have selected earlier. So I cannot just put the key somewhere without authenticating first. I need to put the root password here so machine can know that it's coming out actually from the legit user. Okay, I put the password, I distributed the key, number of keys added 1, excellent. So now basically we can SSH from this server to our remote server. Okay, now we can change the IP and distribute the public key to our another remote machine that we are managing. So it's here instead of 170, the ending is 122, and it's pretty much the same procedure. We can see that we have The key will be installed in the /root.ssh idrsa pub, which is the public key, and now we can see that the key was installed. Excellent. So now when we have, of course, I also need to authenticate as a root user, and that's just excellent. We can go to our Ansible project folder that I started, where we will keep all of our playbooks and inventory files. Speaking about the inventory file, it's actually the first file that we are creating in our project. It's a very important one because here we're going to tell Ansible which exactly nodes it should connect to and how to connect to these nodes. So this is our basically, well, the inventory of all our remote machines that we are going to work with. Okay, so what Ansible really needs is to have the IP, the name of the user, and which private key here on this local control node it's supposed to use to connect to the node. So I'm going to select the user, Ansible user, it's root. And now apart from that, we also going to, I'm just going to copy paste that. Okay, and now the root. Apart from the root, I also need to put the name of, need to put the IP of our remote machine. So it's, I just copy paste from Linode cloud dashboard. Okay, and here the last parameter that I need to tell Ansible where to look for the private key. Okay, so my private key to that will be used to create the secure tunnel is actually in the /root.ssh id RSA. So this specific key please use to authenticate to our remote machine. I'm just going to copy paste the Linode Ubuntu, and now I'm going to define another machine, which is the CentOS. Okay, so of course here the only difference is the different IP, but it's also supposed to use the same private key that I just created. So I'm just changing from 122 to 170, and we save the file. So what I'm doing now is just putting the ad hoc command, which is a quick way to verify, for example, connectivity between two different hosts. And in our case, I'm going to use the ping module, which is like a predefined software package that we can use to build our Ansible scripts. And we can see that the connectivity was successful because the both machines replied to our ping with the success, and that means that we now having access to the control node, we can provision, we can provision configuration to our remote nodes. I can run some other quick ad hoc command, which is, for example, which is using shell module, a different type of the predefined package. I'm just going to run ls, and we can see that Ansible printed for us the files that are in the current inventory. Okay, excellent. Having that already defined, having that already done, we can now move on to more complex configuration, writing some more advanced playbooks to present you with the Ansible security features. Ansible security feature number 2, users creation and management. Let's be honest, it's one of the most common tasks for a DevOps, IT, or Linux admin engineers to properly manage the users. People joining our company, people leaving, and we need to have it under control on who has the access to our infrastructure and on which specific level. So in this lab, I would like to show you how we can use Ansible to automate the process of providing and giving the permission, assigning the users to the specific groups, for example, to the normal developer group, and also, for example, to the sudo group. So let me show you how we can actually utilize Ansible to automate the user creation. Let's go to the lab. Okay, I am already in my console. Let's now just create a new playbook. So the playbooks, apart from the ad hoc commands, are the main way to provide the tasks to our remote nodes. So let me start with the first, giving the name of our playbook. So in our case, that will be user creation. So here we'll define the creation of the users and management. So I'm just going to say that all of the hosts that we have in inventory shall be impacted by this playbook. I will also run the playbook in the become mode, which is like a sudo, and here I'm also going to provide different variables. So here I will have two sections of the variables. So the first one will be the normal users, so the ones that I will create without the sudo access, like John A and Alice B. And then apart from that, I'm also going to create the admin users. So this is the group of the users that will be created with the dedicated sudo rights. So I will just have a one user called admin user. Okay, now we can move on to the creation of the tasks. So the first task I will be creating is creation of the group devs. So for the devs group, I'm going to assign both normal users, which is John A and Alice B. So to create the to create a group with Ansible, we're just going to create the task. We're just going to say create group devs, and then I'm going to use the group module, which is something that is already predefined by Ansible with all the parameters that I need to provide to our Ansible. So basically just the name of the group and this state, which is present, means that it's supposed to be created. Now let's move on to the second task, which are the creation of the users. So I'm just going to create the users and add them to the dev group. So this will be handled by just one task. So for that, I'm going to use the user module, which is something different than the group module used in the previous task. And let me just copy both parameters. Okay, and now I'm going to also create the user. For that, I'm going to use the loop. So I'm going to iterate each item. I'm going to loop over normal users John A and Alice B to be created. And also I'm going to assign the default shell for the user, which is a bin bash. With state present, we're going to ensure that the user account is present. Okay, excellent. So in this task, I'm using the loop mechanism that will be looping through the normal users that I have defined in the variables, and pass them to the task that create normal users and add them to the group. Okay, I'm now just going to copy paste these lines, and now I'm going to create the admin users. So here we have this similar mechanism. So this task will also loop through the admin users to create the admin users. Okay, so here we are just going to change the name of the task. So here, instead of the normal users, we'll have the admin users. I just need to change that. And I'm going to use the if statement. So this basically, if the OS is based on the Red Hat, like CentOS, the admin group is will. Otherwise, all other Linux families like Ubuntu will go to the sudo group. Yes, excellent. And now we're also going to run state present, which is the ensuring that the admin account were created. Here I'm just going to change small typo from yes to all, and now it's time to run our playbook. So let's run it, and basically we can see that the playbook was successful because all of the variables, all of the tasks were executed correctly. We got 4 OKs, 3 change, meaning that that creation and the assignment of the users to the group was successful. Okay, to verify the change, I'm going to quickly run the ad hoc command. So to do that, the syntax is the first, I'm going to run Ansible, first, then the name of the node. And in this case, first I'm going to run for the Linode Ubuntu, and then I'm passing the inventory file, the module that I want to use. In this specific case, I'm going to run shell module, and the passing argument will be, I will just less the etc password, which is the shell that I'm going to execute on the server. Okay, and now we run it, and we can see that we have 3 new users created on our Ubuntu machine. So it's John, Alice, and admin user. And now what we can also do is to run quick ID command to verify the groups that all of these users belong. And now I'm going to run quick shell command, which is ID John A, and we can see the parameters of that user, and we can see that the user was added to the developer group, which is exactly something that we wanted. The same we can do for admin, and we can see the admin is part of the sudo group, which is something that again we defined in the playbook. Okay, excellent. Security feature number 3, Ansible Vault. So Ansible Vault is a utility that can help us with encrypting and decrypting the data, the sensitive data that shouldn't be kept as a plain text. Data such as, for example, API keys, credentials, database credentials, of course, passwords, and all of this type of sensitive data. So basically, rather than hard coding the passwords into our playbooks, we can put them to the vault where they can be kept in secret. Let me show you how to do it. We're first going to create database on both Ubuntu and CentOS servers, and then we're going to create the users task with the user that we allow to authenticate to our database, but we'll hard code the password in our playbook. Later on, we're going to move the password into the vault so it cannot be read in the plain text, and then we're going to run the playbook one more time. Let me show you how to use Ansible Vault with this example. Okay, let's set up our playbook. We will call it database.yaml. So here, first thing I'm going to do is going to target all of the hosts defined in our inventory. So this will be both Linodes in our case. I will run that as a beacon that ensures that we have elevated privileges, meaning sudo, to run this playbook. And now we're going to define our tasks. So the first one will be to install MariaDB server with the package module apt, which is used for the Debian-based distributions. And here we are going to define all of the needed parameters, such as, for example, MariaDB server state, which is present, meaning that we want to have MariaDB install, and here with when I'm going to define the condition. So this task will be only executed if the operating system is part of the Debian family, ensuring that it runs on the Ubuntu, not on the CentOS. Okay, great. So now we have it, it's already done. Now I'm going to copy paste this task, and now I'm going to write the same for our CentOS. So in this case, I'm going to change the name, so it's going to be CentOS. And then instead of apt, I'm going to use yam. And of course, I need to change the OS family, which is going to be Red Hat. So the same condition, just like in the previous case. And changing the module, I'm going to use yam for that, not the apt. Okay, now let's having this done. Now already we can, after the installation, we can start and enable the MariaDB service on our servers. So I'm going to write the task that I'm going to name start and enable MariaDB service, and here, rather than the package manager, I'm going to use service modules. So that will ensure that the MariaDB service is both started and enabled at the boot time. Of course, the name of the MariaDB service, we are going to define two more parameters, which is state and enabled, which ensures that a MariaDB will automatically start on the boot system. Let's just run to make sure that everything works. So I'm going to type Ansible playbook. You already know the syntax, and select our database. Okay, we see that everything runs quite nicely. When we have the task that is only for Ubuntu, like for example, install MariaDB on Ubuntu, it's skipping the CentOS Linode, and then it does the same for CentOS. It's skipping the Ubuntu task. Okay, but let's just now move on. Now, when we have that already settled, we have started and enabled our services. We are going to define our user, so the one that will be authenticated to go to our database. So here I'm going to use a different type of module, which is MySQL user. As a name of the task, I'm just going to put create database with name John A. And I'm going to also put the password 12345 with all database privileges. And again, this is just for the demonstration. It's not recommended to hard code any password. We are just going to demonstrate how Ansible Vault really works. So just for the demo purposes, I'm hard coding the passwords in our name of the task. But let's continue. So again, I'm putting the name of our module, which is the MySQL user, and then I'm going to put the name of our user, which is John A, as the name of the task indicate. The password is 12345. This is the plain text, which is insecure, of course, and all the privileges on for our database. So here I'm also going to write. The playbook also connects to the DB with the I'm also defining the user that has already the access to the database. I'm not going to dive into the details because this is just pretty much Ansible Vault exercise, but what you need to know is that here this the user that I already have it here, so the root with the specific password, this user already has the full access to database. I am now just copying paste the task, so I will create a second user that will also have possibility to go to our MariaDB database. So this one is called Alice, and here, just like in the previous example, I am hard coding the password, which is again insecure option. Please don't do it, use Ansible Vault. I'm going to show you how to do it in 1 second. I'm just changing a few parameters, so it's a different name, different user, different password, but rest pretty much stays the same. So when it comes for this login user root and login password admin, so these ones are specified credentials that Ansible will use to connect to the MariaDB in order to execute database related tasks. So Ansible login user root, that will basically tell Ansible that we're supposed to use root user for MariaDB to perform operations like creating the users or managing the privileges. And of course the password of the root user is how Ansible is authenticated right now when connecting to the database. But what is important now is how we can actually get rid of these hard-coded passwords. So let's just run the playbook to see whether everything works. So again, the syntax that you are already aware of. So Ansible playbook, we run all the tasks, and we can see that, okay, these are all successful, and we created the John A and Alice B users. But now we need to get rid of these hard-coded passwords that we have in our playbook, because we cannot just have credentials hard-coded in the middle of our code. So basically what we can do is to move these hard-coded passwords to utility called Ansible Vault. Okay, let's just now move to our Ansible Vault part. So I'm going to run Ansible Vault create, which will create the new vault for us. I will just call db credentials.yaml, and Ansible will ask me for the password to our vault. So new vault password, I'm just going to type the new password, confirm the new password, and we are all set. We can put all the secrets that we need to our vaults. And of course, I'm going to put the password that I hard-coded into our playbook in the previous that I hard-coded to the playbook. So all of the password that you have already seen, so John A, Alice B, and our admin password, I'm just going to put it here rather than in our playbook. And then in the playbook, I will just tell Ansible where to look for these specific passwords. Okay, so let's just put the passwords. Okay. Admin. Okay. And let's just save it. And of course, I need to tell Ansible where to look for the password. So I'm just telling him, hey, please look for the password in this specific database file, database credentials YAML, sorry. Okay, if you would like to see the content of the vault, we can see that it's already encrypted. So when I cut the YAML, it's already it's not readable. Let's just run the. If we would like to open the vault, we can just run Ansible edit db credentials.yaml. We're putting the password that we selected earlier, and we have the access to our credentials. Maybe I can actually change the name of our credentials, and I will just put John A password, Alice B password, and admin and root password I'm also going to change. Okay, let's just save it and change the configuration in our playbook. So now, now we can change the passwords from the hard-coded passwords to the variables in the Ansible Vault. So I'm just going to put John A password, so the variables that I have defined in our vault. So this variable contains sensitive information. This is why I have it in our in the vault, of course. And the same I'm going to do for the root password. So when the playbook will be run, our Ansible will decrypt the variables and will be able to authenticate to the database by reaching for the variables that are in the vault. But let me show you how to do it. Now let me change all of the passwords. So instead of the hard-coded password for Alice, I'm just going to put the variable, and the same for root, and just changing it here. Okay, so this is already set. The playbook is almost clean. I also need to remove the password from the name of the task. And we are, I think, all set, almost. Just removing the passwords from the title of the task. And we can save and quit. Okay, we are all set to run the playbook, so I'm just going to run Ansible playbook-i and providing the inventory, and then apart from the name of the playbook, of course, and then of course I also need to provide the ask vault pass. So the option ask vault pass really tells Ansible to ask for the password to unlock the vault file and during the runtime. So this is why I'm just putting this right now, and of course I need to put the vault password that I have selected earlier, and we see the playbook beautifully running. It doesn't show any hard-coded passwords. Everything ran pretty smoothly, and we can see that there were no changes because the users were obviously already created. And when we run cat on our playbook, we can see that all of the variables are beautifully are already encrypted by Vault, that is also referenced in the playbook. So that's it for this specific, for the Ansible Vault. Let me now show you how we can manage firewalls with Ansible. Ansible security feature number 4, firewalls management. Firewalls are really our first line of the defense to our infrastructure. They control incoming and outgoing traffic to and from our servers. But managing firewalls can be very difficult if you have multiple servers with the different OSs, with the different services and rules that you need to apply for the system to work. So this is where Ansible can really help. With Ansible, we can automate a lot of tasks that are related to firewall, and we can control the specific rules just from the one place rather than going to the machine and configuring each of the firewalls separately. So let me demonstrate how we can actually use Ansible to manage firewalls on our infrastructure. What we are going to do is basically write a playbook that will first start the Nginx service that will be operating on the port 80, and then we'll also install Firewall D and uncomplicated firewall on both Ubuntu and CentOS. Having that already in place, we'll successfully block traffic on port 80, so you can see how easy it is really to block and control the traffic using Ansible and firewalls related modules. Let's go. Okay, so now I am already in my control node. I'm just going to start a new playbook. I'm just going to call it firewalls, and let's start to code. So basically I'm going to define all the hosts. I'm going to run the playbook in the become mode. So this is why I put yes next to become, and now let's write the task. So the first one will be, of course, to install Ubuntu. Sorry, the first task is to install Nginx on our Ubuntu. For that, I'm going to use the apt module. So this is something that I already showed you in the previous examples. So the package that I'm going to install is Nginx, and I want to have it present, which is I want to have it installed. I'm also going to update cache. So I'm also going to write update cache, and here also going to here I'm also defining that this specific task will also only run for the Debian based distribution of the system. So in this case, will also only run on our Ubuntu Linode. let's just copy paste the task and write a similar one for our CentOS server. So here just a few little changes. Of course, instead of Ubuntu, I'm going to run here. Instead of Ubuntu, we'll have only CentOS, and of course we need to change the package manager, which is not the apt but yum. Yeah, just here, changing from apt to yum. And of course, we will run this task only when the Ansible OS family is not Debian but Red Hat. Alright, so far so good. We can actually run this task and we can run this playbook and see whether everything works. So I'm going to just run Ansible playbook, provide the inventory and the name of our playbook, firewall.yaml. We can see it's running, and playbook successfully install Nginx on both our servers. Great. Now what we can do is to enable the service and also make sure that it will start the service every time the machine will boot up. Okay, so let's just come back to our playbook, and here I'm going to create a new task, which is ensuring Nginx is started and enabled. On both Ubuntu and CentOS. Okay, so for that I'm not going to use yum or apt, I'm going to use the service module, and the service that I want to make sure that will be managed is Nginx, state is started, and of course I want to have it enabled. I'm not putting any when because this will be applicable. This task is all applicable for both servers. Okay, we have a small typo here. We're just going to put the service. Okay, and now having that already in place, we can start configuring our firewalls. So we have Nginx running and started on our servers, and now we can start to define the rules on our firewalls. So the first thing we need to make sure is that firewalls is actually installed on our server. So here I'm going to run enable. The first thing we need to do is to make sure that the firewalls are enabled on our server. So here I'm just going to use not the apt yum or service, but UFW, which is uncomplicated firewall package module dedicated to work with the firewall related tasks. And here also going to put only when the Ansible OS family equals to Debian. And the next task is basically in this task we will start to configuring our firewall. So for that, let's just write the first rule will be to allow HTTP port 80 traffic on our Ubuntu. So in this case, a firewall will be allowing the traffic on the port 80, and here I'm again using the UFW module. And here's some parameters. So basically I need to write the rule, which is allow or deny, as we'll see in the next example, port 80, and the next one is proto, which of course refers to the protocol. In this case, we're just going to run TCP, which is the protocol that HTTP uses. Okay, and I think so far so good. And of course, I'm also going to run this task only for Ubuntu OSs. Okay, I think here it's like a small typo. We can change it. Okay, let's just run the playbook. And it's pretty much the same. I'm going to run Ansible playbook inventory firewall, and it's running. Okay, we have our new task, and we can see that everything was successful, and I'm just going to put the page with Nginx on our Ubuntu servers, and we can see that the traffic on port 80 is allowed, which is something that we just told Ansible to do it. And while we actually here, I'm also going to show you a documentation for Ansible, because I'm not taking all of these parameters for management of the firewalls just from the memory. Each of the parameter is very well defined in the Ansible community documentation. So if you need to write some rules or create some task, please always refer to community documentation. It's really excellent. The only thing that you need to do is basically copy paste the task and tweak it to the way that you basically need it. So for example, in this case, we can see many different tasks for SSH, for port 80, for really many different things. So but it's something that I definitely recommend when you work with Ansible, to read the documentation and read the documentation. Okay, let's just now come back to our playbook, and how about we will make some tests, and now instead of allowing the traffic on port 80, let's just block it. So of course, rather than, we need to change the rule, and here rather than allowing the traffic, we need to deny the traffic on port 80. You see how simple it is? So basically, instead of allow, we're just going to put deny, and here in the rule, I am denying the traffic. Let's just write the test right away. Just need to find the playbook. Okay, and the execution was successful. Now we can see whether the Nginx will work, and we can see that Safari cannot open the page even though the IP is the same, because we are successfully blocked the traffic on port 80. So that's just exactly what we wanted. Now what we can do is also to see the rules of our firewalls. So this is already our remote machine. I open it, I SSH there specifically for that exercise, and we can see this is the configuration of the firewalls that we made. So we can see that the port 80 was blocked, and that is deny base for both IPv6 and IPv4. Okay, let's move to the another part, which is the firewall D. So this one I will use to manage the traffic on CentOS. And again, just like in the previous example, we can refer to some specific modules, and everything basically what I put into the playbook comes from the documentation. So remember, when you do some labs on Ansible, you should always refer to the documentation, because it just has so many different examples that we can just, reuse. So the first thing I'm actually going to do, so this time actually what I'm going to do is to install Firewall D on CentOS, and for that I'm going to use the yum package, and this is only again for Red Hat OS family. So this one will only run on the CentOS Linode. Now is to start creating the rules. So to do it, I'm going to basically define the new task, which is, for example, let's say which will be permitting the traffic on in our default zone on port 80. So this is the task from the documentation. I will tweak it a bit. So the module, of course, is the Firewall D. Pretty much the same syntax like in the case of uncomplicated firewall module. So here we are just defining protocol, the rule, and here I'm going to say enabled, which means that we'll be permitting the traffic on our node. So here permitting the traffic on port 80, and here I'm just going to run Ansible OS family equals Red Hat. Okay, and now we can just run playbook. Now we are running the playbook. So again, you already know the syntax. I'm providing the name of the playbook, which is firewall.yaml, and we run it. Excellent. So it's basically permitting the traffic on the default zone on port 80, which is something that we want. So now when I open the Nginx starting page, we should see the we should see the welcoming page, and we can see the server test page. You see the IP is already different. It's CentOS, which is something that we this is what we actually configured in our firewall. But let's just do a simple test. Instead of allow, we'll just deny the traffic and the state will be disabled. Let's just run it, and then we should able to see that the traffic is not permitted. And we can see that the stage has changed. It's also worth to really reload the firewall after the change. So I'm just going to run a quick task, which is the reload firewall. So for that, I'm going to use the command module, which is execute. It's just like execution of the bash command on our server. In this case, it will be just firewall cmd reload, and only for the Red Hat distribution. So what we are going to do is basically we're installing the firewall D, configure it, and then after the configuration is done, we'll just reload it. You can also use handler for that, but this is just the firewall demonstration. Okay, we just run it, and we see that it is successful. Basically, all the tasks were executed. And when we open the page, we can see that the site cannot be reached, which sounds about right. Which is the same IP. Okay, that's it. And now let's move on to the last example of our Ansible security journey with the package upgrade. Ansible security feature number 5, package update. So whether you are running CentOS or Ubuntu, really regular package update is very crucial for our systems. Not only because the new packages really brings a better performance, improvements and bug fixes, but first and foremost because of the security vulnerabilities. It is very crucial to keep all of our servers at the highest possible version of our packages. But let's also be honest, going to each of the servers and updating the packages manually can be really time consuming. So rather than going there separately, we can just write one simple playbook in Ansible that will do it for us and automate this process. Let me show you how to do it. Let me write a very simple playbook that will automate the package management on our server. Okay, let's just open the playbook. The first thing I'm going to write is the name of our playbook, which is update packages on both CentOS and Ubuntu Linodes. Okay, now let's put the host, which is basically to specify that the playbook will run on all the hosts defined in the inventory, and let's run the first task. So the task name is update packages on Ubuntu. This one will be specifically updating the packages on the Debian based system. So here I'm going to use the apt module, and here also going to run update cache. And apart from that, also going to write the upgrade dist. And of course, when Ansible OS family equals Debian, so this one already you know. Let's just copy paste the task because the CentOS will be very similar. So here, instead of packages on Ubuntu, we're just going to change to CentOS. And here, instead of apt module, we're going to use the yum module. So this one, of course, manages the packages on the Red Hat based systems. Then apart from that, also going to remove the update cache, but I'm just going to put name asterisk, so that really makes sure that this targets all of the installed packages on the system, telling the package manager to work with every package install. And what I'm telling Ansible to do is to basically ensure that all packages are upgraded to the latest version. And now OS family equals Red Hat. Okay, we can just now run our playbook. And we can see all of the tasks are running. It can actually take a moment because now Ansible is updating all the packages on our system. So I'll just move fast forward this part a bit. And we can see that the changes were successful, and we can see that Ansible changed, there is a change on Ansible Ubuntu, there is no change on CentOS, maybe because I was running the YAM update before, so I had already the highest version of the packages, and that's basically it. So this is really useful and very efficient, because it's, again, we don't need to go to each of the machines separately, we can simply do it from Ansible. And I would also like to go to the Ansible documentation, and we can, because all of the playbooks that I'm running are based on the official documentation, Ansible community documentation, and we can see here that we already have the pre-made prepared the pre-made task that we can simply just copy paste, and there are really many great examples that you can just simply reuse in your playbook. So of course, like this one, update all packages to the latest version. So this documentation is actually dedicated for apt module. Excellent, and that will be it for today. Thank you very much for watching. There are just so many great features that we will really able to go through. And remember, if you also would like to lab it hands-on, try yourself with the Ansible, you can just use the link in the description to spin up the Linode on the cloud dashboard. So I hope you enjoyed this episode. You are now able to implement all of these features into your infrastructure to make sure it will run more securely and more efficiently. Thank you very much. Bye.